All right, welcome back, Chem students. This is the third video, okay, on stoichiometry. And this time it deals with the same problem from before. And if you need to go back and watch the other videos, by all means do. I will have video 2 that was like a pre-done before this particular problem, because there was a part A and a part B. Part A was asking you to calculate the moles of carbon dioxide in water. Well, this time you have a part B, but guess what? These are completely different numbers. So you have to do these problems using the new numbers that they're giving you in this particular problem. So I'm going to go ahead and show you how to do part B. And I want you to watch how I solve these problems. And let me tell you, it gets no better than this because they're all simple steps. All simple. So let's go ahead and show you how to do the very first problem. And you know what? I'm going to change the color. I want purple this time. So let me go ahead and hook us on up and let's get to the problem. It says if 0.647 moles of oxygen are used in the burning of propane, how many moles of each carbon dioxide and water are produced? How many moles of C3H8, aka propane, are consumed? So guess what, guys? You have 3 problems, but you're going to do them one step at a what time? All right, let's get into it. So I have given you 0.647 moles of oxygen. And what I want to know is about carbon dioxide, water, and propane. But remember, you cannot do them 3 at a time. You got to do them 1 at a time. But I'm going to show you a trick. All you got to do is when you set the problem up, what will never change is 0.647 moles of oxygen over 5 moles of oxygen. That side will always stay the same. What you're going to be looking for are the moles of carbon dioxide and the moles of water and the moles of propane. So watch how simple I am about to make this happen. Okay, just watch. Keep on watching me. Keep on watching me. Okay, so all I'm going to do, just to show you all how simple this is in terms of what I mean about setting it up, since I'm looking for the other x's, okay, I'm going to come down here and I'm going to change my pen color out so you all can see that it's the same setup, okay, same setup. So as you can see, I've got the 0.647 moles of oxygen over 5 moles of oxygen, and that's equal to X moles of water over 4 moles of water. So again, I'm looking for that new X. And then I've got one more X that I'm going to be solving for, and that's for propane. So I have, again, 0.647 moles of oxygen over 5 moles of oxygen. That's equal to my X moles of propane over 1 mole of propane. So I'm going to zoom out so you all can see this particular problem, okay? And you can see how what we were doing here is simply based on this equation right here at the very top, okay? This equation right here is the foundation for these 3 problems down below, okay? So all I'm going to do, guys, is do what I've said before, and that's cross multiply, okay? So I'm going to take this number here and multiply it times this number, and then divide by 5. I'm going to do that for the next part. I'm going to take this number here, multiply times 4, and divide by 5. And in the last problem that I'm solving for propane, I'm going to take this number here and multiply by that number and divide by 5. Okay? All right, so let me go ahead and show you the setup over here in terms of the math so you all can see, again, the final solution. So 0.647 times 3. Okay, 0.647 times 3 divided by 5. And that's going to give me my first answer of what you see up here, the 0.388 moles of carbon dioxide. The next one, let me go ahead and get the green, okay? Again, we're going to take the 0.647 times 4 divided by 5. And again, that's going to give you 0.518 moles of water. And then the last one that we have, I'm going to do the same thing, 0.647 times 1 divided by 5. So again, you will get this as your final answer. Nothing to it, guys. Nothing to it. Stay tuned for the last type of video where we're going to go into grams. So far, we've been doing mole to mole problems where I've given you moles, I'm asking you for moles. Now, in video number 4, we're going to show you how to go from a mole of oxygen to a gram of oxygen. It's just one last step. Stay tuned.